In the video 5.12, we calculated the probability of seeing 5 emergencies, 4 emergencies, 3 emergencies, and so on out of 5 visits to an emergency room with a probability of 0.646 using the formulas on page 154 and 157. Now we're going to calculate the same set of emergencies using the same probabilities, but we're going to do it with the BINOMDIST function, which is one of the functions of Excel. In order to do that, we will use the BINOMDIST function, and the first argument is the number, in this case the number of emergencies that would show up out of 5 visits, then a comma, and the number of trials, in this case that is 5 again, and we'll fix that with an F4, and the probability associated with those trials, which is 0.646, and again an F4. And finally, whether it is a cumulative probability or the actual probability. Here I'm going to put the actual probability. The actual probability will be 0.113, just as we see here. If I now click this all the way down, I get exactly the same results here as I have here. These are the actual probabilities based on the BINOMDIST function. We can also calculate with the BINOMDIST function the cumulative probabilities. It's exactly the same formula, equal BINOMDIST, again the number of trials, the probability, and now instead of a 0 we'll put a 1 for cumulative, and when I hit enter I actually get 1. So if I accumulate all of the probabilities from bottom to top, I get a total value of 1. If I click this down, here are the cumulative probabilities from 0 up. So the probability of 0 is 0.006. The probability of 0 or 1 is 0.056. The probability of 0, 1, or 2 is 0.241, and so on. I can get exactly these same values, that is, the values here, by accumulating from the bottom. So that as I drag this up, I get exactly the same values that I get using the cumulative distribution function for BINOMDIST. This will be true of the binomial distribution, which is a discrete distribution. These are discrete values. There's nothing between 4 and 5, for example. This will not be true of the normal distribution, which is a continuous distribution.